Hey guys, welcome to Pepcoding. Today we are going to learn a question max frequency stack. So basically what is a stack? In a normal stack what we do is we simply perform LIFO. Okay, we push from here and we pop from here. So it's like 10, 20, 30. When we pop, 30 would be removed. But what about in max frequency stack? It is a different kind of stack. Let's see what's our problem. Here our problem is, suppose here I have 10, 15, 10, 10, 15, 20. So in normal stack, if I remove, then 20 should be popped. But here 10 has a frequency of 3, 15 has a frequency of 2, and 20 has a frequency of 1. So 10 has maximum frequency, so 10 would be removed. Now what? Now 10 has a frequency of 2, 15 also has a frequency of 2. So if we pop now, then they both have same frequency, but 15 is at the top, so 15 would be removed. Now 10 has more frequency, 10 would be removed. Now 15, 20 and 10, everyone has a frequency of 1. So 20 is at the top, it will be removed. 15 is at the top, it will be removed. Then 10 will be removed and then the stack would be empty. Okay, so this is our problem. Let's see how we would solve. I don't think we can solve it like this. How would we do this in one stack? But no one has stopped us from using multiple stacks. So we can use as many stacks as we want. So let's use a hash map of stacks. Let's create a hash map which contains many stacks. So what kind of hash map I am talking about is, see, this would be my hash map. This will contain stacks. Its key would be frequency. And I would be having a stack of values. So suppose my input was 10, 15, 10, 10, 15, 20 for push, then I performed pop function 6 times. So how will it get push and how will it get pop? Let's see. So there are, like, first 10 would be push. So 10 would be having a frequency of 1, so it would be pushed against 1. A key value pair would be made, key would be 1, an empty stack would be made and 10 would be pushed in it. Then 15 would also have a frequency of 1, it would be pushed here. Then 10 would be having a frequency of 2 and it would be pushed another key. Okay, but what? How will I get to know that 10 has frequency 1, 2 or 3? So I'll use another hash map. Okay, so when 10 was not there, then I put value 1 against 10. Then 15 was not there, I put value 1 against 15. Then 10 came, so I changed its value from 1 to 2. Then 10 comes again. Now I'll go and check. Its frequency is 2, so I'll update it to 3. And I'll check if frequency 3 key exists or not. It's not there, so I'll create a key and add a stack to it and push 10 to it. Then I'm asked to push another 15. So where should I push 15? I'll go and check its frequency is 1, so I'll update it to 2. Now I'll go to E2 and push 15 here. Then I need to push 20. So I see here there's 20 is not there, so I'll put 20 and its frequency would be 1. Then I go to frequency 1, I'll push 20 here. Okay, so now what? Now I have to pop 6 times. First pop function would be called, then I go to, this is my design. This hash map name is design and this name is fmap, frequency map. So I go to my design and I call for design.size, which is this. This would be the maximum because frequency would be like 1, 2, 3, 4 and the maximum size would be the maximum frequency. The size of the design would be the maximum frequency, so I'll go to 3, I pop 10. Now if the stack that is in key 3 gets empty, then I need to remove the key value pair. Okay, so 10 would be printed. Then I'll again pop. Now the size is 2. If I go to 2, I pop, so 15 would be popped. Here frequency was changed from 3 to 2 again, and here from 2 to 1 again. Then again I'll call pop. I'll go to 2, 10 would be popped. Size is 0, so this would be removed. Then I'll again call pop. I'll go to 1, 20 would be popped. Its frequency would change to 0. So if it is 0, then we will remove 20. And 20 would be printed here. Then again pop. I'll go to 1, 15 would be popped. Its frequency will change to 0. 15 would be printed here. It would be removed because it's now 0. I go to 10, it would be popped, printed. Its frequency would be changed to 0. Here it was changed to 1 in this case. Now it would be 0. Since it is 0, so it would be removed from map and it would be printed. And since this stack is empty, it would be also removed. Now my design and fmap both are empty and my pop functions are also completed. And this is my output generated. Okay, so let's see. Ones who want to code this on their own can code, others can see my code. So let's code this together. Okay, so first we need to create two hash maps, design and fmap. Okay, so hash map of integer versus stack, and this stack is of type integer. Its name is design. Okay, another hash map of type integer. Okay, this would be fmap and it's of integer versus integer type. Okay, so cool. Now we need to initialize them. So design equals new hash map fmap is equals to new hash map. Okay, now in push function we do two types of operation. First we check for fmap if we have the value or not. If we have it, we simply update its frequency, or we create a new key value pair with value and a frequency of 1. Second thing, let's first do the first thing, then we'll talk about second thing. So what do we do here? We simply do fmap dot put fmap dot get or default. What will this do? If we have the value, the key is val. If we have something here, then its value would be returned, else 0, and we need to add 1 to it. Okay, so now we have changed the frequency of fmap. Now what we need to do is, let's create a key. So int f equals, the frequency is fmap dot get val. Now we have the frequency. Now what we'll do, the second work. The second task was to go to the design and check if the frequency f is there or not. If it is there, then if it is not there, then what do we need to do? We need to create it, a key value pair with the empty key is equal to f and a empty stack. Then we need to simply add the value in the stack. So if design dot contains key f, if the key is not there, so we'll put not. If this is true, if the key is not present, then we need to create. So design dot put f comma new stack. Okay, so now we have our stack. If it was not there, if it was there, then it's good. If not there, then we have created one. So now what do we need to do is design dot get f dot push val. we need to add value in the stack. Okay, now let's come to the pop function. What do we need to perform in pop function? Again, two types of things. First, we need to go and check the size of the design, and then we need to delete the element from that. So we need to check the maximum frequency. So maximum frequency mfrec is equal to design dot size. So what do we need to do now? We need to pop. So design dot get m frequency dot pop, and we need to store this result in the answer. We can't return answer right here because we need to perform some more functions, so we are storing it in answer and we'll return answer after that. So now we have popped. So if m design dot get m frequency dot size, if the size of the stack is empty now, then what do we need to do is we need to remove it. So remove, design dot remove m frequency. Okay, now what? Now we have removed the element and we have removed the stack. Now we need to change our frequency in the fmap. So we'll go to fmap. So int f equal to, the frequency is equal to fmap dot get answer. Okay, now fmap, now we have the frequency of fmap. Now we need to reduce it. So fmap dot put answer comma f minus 1, and if f minus 1 is equal to 0, then what do we need to do? We need to simply remove. So fmap dot remove answer. Okay, and simply return answer. Let's try and submit this code. Okay, let's check line 17. Spelling error. Line 22, fmap dot port get our default val 0. Plus 1. Okay, forgot to write val here. We need to write the key also. Let's submit this. Cannot find symbol. This seems to be fine to me. Let's check the spellings. Oh, let's see the spelling. Get or default. Okay, spelling error. Let's submit this now. Line 25. Let's check it. Design output. Cannot find symbol again. Some spelling error would be there. Okay, S is small. Okay, it gets submitted. So guys, I hope you liked the video. Please like, share and comment and subscribe to Pepcoding. Thanks for watching.